Hello everyone, it is February 1st, 2023, and this is the libhal weekly meeting. All right, so the agenda for today we're going to be going over will be some quick mentions. This is a new section we're going to add to the highlights. Basically items that we're not going to make entire slides for just because it's not really necessary. I'll quickly go through these and then we'll go into the bigger items here. Some pretty exciting parts here. So first off, we have a new template repo, libhal library. So if you ever want to make your own library, you can just go here, click on use this template, go to create new repository, add in your name, and so on and so forth. Add it to yourself or add it to some organization that you're a part of. And it'll copy all the different bits and pieces from it. It includes your data sheets folder, your demos folder, a docs folder, an include folder, where your source code is, and the include folder. Test package, your tests, and your workflows to get started. And as well as like the Clang format, Clang tidy, get ignore, license, readme. You can change this to what license makes sense for your particular software. And then also a dummy or a demo Conan file. Now, the word library is used throughout this, and there's a bit of a list here that explains all the files that you need to rename. Like readme needs to be renamed and modified, Conan file need to be modified. You need to like put new files in the data sheets folder, and so forth. So everything that has an arrow to it needs to be edited in some way. Like the targets for the demos need to be set up to use your actual code and what's necessary for your actual code. So this just explains all the different parts and pieces that are here. And then we have some how-tos on how to write a device driver, a target library, and a utility. These are not ready though, like at all. So click on these, you'll go here, but this is pretty much empty. So that'll be added to later. I'm hoping to get device done maybe by the next sprint, but target's going to be a while. Maybe the next sprint or the sprint after that. So that's the template repo. So if you ever need to make your own, if you want to make your own library, you just click on get this link. It's on libhal library, and just do create a new repository. Next up, we also have a new target library. It is the libhal stm3210x. This has pretty much the same thing as library does, but in this particular case, this is set up for the libhal stm. We need to fix up some things in coverage so that this all works, but we'll do that later. So that's happening soon. Hop in the next sprint. Also added in the GCC 12.2 into the packages. Ooh, actually, there's a thing that I forgot to explain as part of this whole list here, and I guess I'll explain it verbally. So before in the instructions for installing things, you had to include let's go to install prerequisites. No, it's actually in trying it out. Yeah, you would need to do the whole Conan install, build type debug, and build missing. This was always extra. You always didn't have to write this just because this part here sets the build type directly to debug. Then you could set it to release if you want to, explicitly. And also included build missing, which is what the ARM toolchain, the GNU ARM toolchain required. But there's actually a flag you can set in your recipe that says that we never actually, we always build ourselves from scratch each time. And that can be found here. So click on this, and then go here, and go to Conan file. You can see that it says build policy, always build. This allows us to remove that flag from the command line. So in a little bit, I will remove both of these actually, because they're not necessary. These are technically necessary unless you add the CMake build type variable into your CMake file. Then you can eliminate having to write this. And then also the same thing goes for this line here. I've already made a change to the robotics teams repo in order to include both of these inside of the project. So all you have to do is do cmake ... Makes it far less verbose. It makes it a lot easier to understand, at least for beginners. So that's one thing to keep in mind. But yeah, we have GCC 12.2. It has even more features from C++ 20 and more features from C++ 23, and as well as also some new features from C++ 17. So 12.2 is good, but almost none of the projects need it, so none of them are really moved over to it. So it's there and available, but you don't really need it yet. Next up, we also have this thing called latest version badge. If we we click on this, it'll bring us to libhal, and you'll see that we have this badge called latest version. So the package below for Conan says that our version is 000. That's the version that's actually on Conan. We also have our latest version, which is on our local, which is on our the bleeding edge, the repo itself. So this gets generated as part of the CI system. It gets built by default for anyone who takes in the libhal workflows. So you automatically get this for free. If you go to a library that doesn't support or doesn't have a Conan Center package, like for example, we can go to let's say librmd should be supported. Yeah, it just says dash, so it doesn't actually show anything. Once we actually add support for this particular button will update itself. This is just useful so that when you come over to a library, you can very easily see what version it is versus having to go to the Conan file py and go from here. We do at some point need to start adding in releases, so each time the Conan file py updates, we actually add a new release here. That way it's also a little bit easier to see which releases are where. And also for people who want to have it all prepackaged, it also makes it easier.
I saw that the other one had it.
Oh yeah, I updated that manually. So I don't have that as an automated step, but yeah, I updated this one recently to 3.4. I was considering having that be the version that we just kind of post a new version to, or the new version that I post to Conan, but not super necessary. The one thing that's really cool though is that it can give you a list of all the changes that you've made from 00 to now, going from the oldest on the top to the latest on the bottom. Most of these are just me, but yeah. Yeah, so that's the latest version badge. And then also, we have LPC 40XX now has an I2C driver, so that's available. So anyone who's using the LPC 40 series of chips now has I2C. All right, next up we have libhal sensor interfaces. So quite a few new interfaces added in. Most of them are just sensors, or all of them are just sensors. We have accelerometer, gyroscope, magnetometer. We have distance sensor, rotation sensor, and temperature sensor. These do exactly what you might imagine. These are all links here, so you can go to the slide deck and then click on them to go to them. I'll show off just a couple of them. For example, accelerometer. Here we just have a read struct that is G-force X, Y, and Z. And that's pretty much it. It's in Earth G's. So, and that's how most accelerometers operate. So most of the time they will tell you like, oh, from 0 to 1024 is 0 to 1 G. So if you have 1024, you just return back the number 1.0. You would not return back 9.8 meters per second squared. And then another case here, we have magnetometer, which is in Gauss. So we have Gauss for X, Y, and Z. And then we can have distance sensor, which is simply just a single field of meters. You just return back your meters. We have temperature sensor, which is just temperature in Celsius, and that's pretty much it. So the other ones are just the same old, same old. I guess the rotation sensor is a little bit interesting in that it's in degrees. That's pretty much it. So yeah, we have new interfaces. This means that we can now, when we start writing things like the MPU driver or the MMA driver or just any old driver for an accelerometer, gyroscope, or things that provide distance, like an encoder or a LiDAR or something like that, we could use this for that. And then also for temperature, which was needed. We now have something that implements all of these. So we can start writing drivers that actually use it. So that's the new sensor interfaces. Next up, we also have HAL print and HAL print N. So HAL print N actually have very different functionalities. Print just allows you to get rid of HAL check, HAL write, serial, blah, 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 to just become HAL print serial and then whatever you want to print out. The assumption here is that whatever serial you pass in for writing is infallible. It'll just drop whatever errors occur. So if you have a serial port that can actually return back errors and you want to catch those, print is not the way to go. If it returns errors and you don't care, like you're just doing logging or something like that, and you can accept having some glitching or errors inside of your logs, then this should be fine. The one with the template argument for size is actually a printf clone. Underneath it just uses sprintf. So now you can do serial HTTP response status %d status here, and this is just the amount of static memory that will be allocated. We don't always know how much memory makes sense, so we want to give that responsibility to the user so they can choose how much they need. Also, a lot of times you may realize that like you can only have a buffer of like 64 bytes because you're on a thread, and the thread only has so much memory available to itself. So that's the reason why we allow you to choose the size of the buffer. We're pretty much almost done. Yeah, we're almost done. We've been here for a couple minutes. But yeah, we have bug fixes for static list and CAN router. So problem, we've discovered that the DRC RMD smart motor, you could send messages to it and get it and control it, but you couldn't receive any feedback. After some inspection, we found that the CAN router was routing all of the messages to a no-op handler. It was still working as intended. The interrupt from CAN was being fired, and it was running the CAN router's handler. But when it would go in there, the CAN router object, the route object specifically, would just call a no-op, which isn't correct. It should be calling the RMD specific handler. So then I went on into some discovery. On destruction, CAN router sets all static list nodes to no-op. Basically, whenever the object dies, the actual things that route to it are still floating around in the code base or in RAM, in memory. And in order to prevent any of those from actually doing anything that could be destructive or problematic, all of their handlers are set to no-op. So even if the CAN interrupt gets called, which actually it should be disabled anyway. The actual CAN. Oh, this rolls back actually. And actually, I think I made a bit of a mistake here. It isn't actually the static list nodes that got changed to no-op. The whole routine or the whole receive handler was set to no-op. The idea here is that you just give CAN a empty function that's statically allocated somewhere, but you just give it an empty function. Hey, you're gonna run this. So it will no longer route to CAN router's handler. It'll just route to some no-op, which does nothing. It just kind of goes in, returns immediately afterwards. But the problem is that this would have on destruction, which is correct, but this same destructor also occurs on the move from object. So we had a move operator. Basically, it's when you move one object from one scope to another scope or from one object to another object. In this case, we always do it from scope to scope. Now, the problem is that the way that we were doing this, we were using this thing called move interceptor, which basically creates two clones. And if you have two clones of something, there's no way for the code to know which one was the moved from object and which one was not the moved from object. All their data looks exactly the same. So that we fixed this was basically by writing a move constructor that would invalidate the moved from object and then allow the destructor to determine which object was moved from and then call the destructor appropriately. All this really comes down to is for the move from object, we basically would set its pointer to null pointer. Actually, I'll show you because I think it's actually a really cool thing to see. Let's look at CAN. Here it is. So, oh, sorry, not here. We wanted to look at CAN router. CAN router. I'm sorry, where is it? That's weird. Where's util? Oh, it's just in CAN. Yeah, so if we go over to this move constructor here, let's get rid of this. We can see, so in this move constructor, we're actually just invoking the operator equals here. So this doesn't really do much of anything. And then up here, we can see that we are moving the M handlers over. This is like the static node that yeah. Not gonna go into that detail, but basically this is what holds the handler for this particular this is the list of all of the handlers, basically. So it gets moved over to the new object. So when the move constructor gets called, you get a reference to the old object, and then you become the moved object. So you move in the handlers from the old object into yours. You move the can pointer over to yours, which is just as simple as just doing a normal equations operator. We set the receive handler to ourselves. And then in order to invalidate the other object, we set its can pointer to null pointer. Down here, we can see the actual objects. We have M handlers, and then we have null pointer for the reference to the can implementation. That way, whenever we run the destructor, so when the object dies, goes away, we check to see if the thing actually exists. If not, then we can't run this function. If it does exist, then we can run this function. And this allows us to move the object, and when the other old object gets destructed, it doesn't cause chaos, it doesn't cause issues. Do the same exact thing for the static list in order to make sure that it worked as intended. And that's something that you don't get for free in C++. If you're in Rust land, you'll know that there's this thing called destructive move, which means that when you move an object, it will no longer consider it for destruction. We don't get that in C++ because it would be too difficult to add it without changing significant parts of the code base or significant parts of the standard itself. So we get this annoyance. And yeah, that is pretty much the little fixes here. So now, CanRouter works as intended, static list works as intended, the RMD class works as intended. New unit tests have been added for both of them. I think maybe just CanRouter, maybe both of them, in order to make sure that this problem doesn't happen again. And that's pretty much it. Any questions, comments, or concerns about what we just went over? Awesome. All right, well, that's it for the video.